Hey guys, and welcome today to a new video. Now today we're going to be taking a look at something new. I'm going to be starting my A-level maths series, so if you hear from my fellow maths videos, don't worry, I will still be doing them. But I'm also going to be branching out into the A-level maths textbooks as well, so this applies for the pure maths and the applied stats and mechanics sections as well. So today we're going to start with the very first chapter in the pure maths 1 textbook, like you see here. This is the AS content. Now it's important, you need to be able to do this anyway. So this is Algebraic Expressions. So this is kind of, basically it's just a bit further on in the GCSE content, so this is like basically very hard GCSE questions. So nothing in here should really be new, just harder versions of what you've seen before. So let's take a look at what we've got here. So the first question is asking us to factorise completely x to the 4 minus y to the 4. So x to the 4 minus y to the 4. Okay, so 2 marks, so we shouldn't expect anything too crazy. But this is just something that comes with time and practice and being able to spot a little trick here. Now the first thing that jumps out to me is that this is kind of the form of the difference of 2 squares. So remember something like x squared minus 1, we could write that as x plus 1 and x minus 1. Now, the reason I'm saying it's like difference of 2 squares is because I've got x minus and I've got this y here. Now, difference of 2 squares obviously will require the difference, quite literally, of 2 squares. Now the issue is this is written as powers of 4, but remember you can manipulate this, right? So this is just the same as x squared squared, right? This y to the 4, again we can rewrite this. This is y squared squared. So it's just being confident with your indices for this question. And notice now I do now have it in the form of the difference of 2 squares. So using this now, we can write this as the difference of 2 squares. So this would be x squared plus y squared multiplied by x squared minus y squared. Okay, and if you expand this, you will end up with just this term here. Now, this is factorised, but it's not factorised completely. Okay, so this is where you got to be careful. This here would probably just get you 1 mark, but we want to get the second mark as well. So to do that, we need to factorise completely. And notice, if you look at both my expressions here again, my 2 brackets, one of these will factorise again. And that one here, my x squared minus y squared, is the one that factorises again, because it's the difference of 2 squares again. So, can't do anything with my first bracket. That just stays the same. This now is just kind of what we've got up here. So it's going to be x plus y multiplied by x minus y. Okay? And then double check it again, see if you can factorise anymore, but clearly we can't now at this point. So here, we've factorised completely. Okay, so this is factorised, but not factorised completely. So just be very careful for that, guys. If they ask you to factorise completely, then just always double check, see if you can go that 1 step further. Okay, so that's the first question. And just if you're new here, I am using the Edexcel textbook, so this was exercise 1C, question 4. Okay, so this is quite a small chapter, and this video probably shouldn't be too long. But let's take a look at the next question. So we're being asked to simplify root 75 minus root 12. Okay, and it wants it in the form a root 3. Okay, now obviously you can't just subtract surds like this. We can't do this. Okay, so what we're going to have to do here is kind of simplify these surds. And the fact that it asks you to put it in the form a root 3 is kind of a big clue, right? What we've got to do is split both of these square roots up here. And what we should get in both of them is a root 3. So, remember when you're simplifying your square roots here, you need a square number. So what's the biggest square number that would go into root 75, for example? Well, I could do root 25 times root 3, right? Because remember, both of them should have a root 3, because that's what we've got at the end. So that kind of gives us the big clue for this question. Do the same for the root 12 now. So that's root 75. Do the same for root 12. So this one's nice and easy. Root 4 would be my biggest square number. So root 4, root 3. And now what we can do is we can simplify our square roots here. So root 25. Again, this is why we need square numbers. So we can write this as 5 root 3. Root 4, that'd just be the same as 2. So this is 5 root 3 minus 2 root 3. And now at this point, now we can subtract the surds, okay? So you can't do it at the start, but we can do it here now. Because essentially the way we'd say is we've got the same base here, this root 3. So I can now do this subtraction to give me 3 root 3, okay? And a is clearly just 3, which is an integer, so we're happy with that. A is 3, which is an integer. Okay, so again, a nice easy 2 marks. And that's that question done. So the next one here, we're getting into some tricky material now. We've got to simplify 3 minus 2 root 5. So 3 minus 2 root 5 over root 5 minus 1. Okay, and it wants us to give the answer in the form p plus q root 5. And p and q are rational numbers. Okay, so there's probably going to be a bit more work to this one. 4 marks. Now, because we've got a surd, a square root in the denominator, what I'm going to expect here is that I'm going to have to rationalise, okay? So, remember when you're rationalising and you've got a square root and a constant, or just a number with it, remember you multiply by the conjugate, and the conjugate is just the opposite sign. So if this is root 5 minus 1, I'm going to multiply by root 5 plus 1, okay? So, I'm going to times by root 5 plus 1. Same again, root 5 plus 1. So we times both top and bottom. And the reason we do this is because what we're looking to do is eliminate the square root in the denominator. Okay, so if we do that, I'm going to have 3 minus 2 root 5. So let's just write this out a bit neater. Over root 5 minus 1 over root 5 plus 1. Okay, so if we expand the numerator now, so 3 times root 5, so what I'm just doing is just expand double brackets, don't be put off by the square roots. So 3 times root 5 is 3 root 5. 3 times 1, that'll just give me plus 3. Minus 2 root 5 times root 5. Well, just be careful here. So root 5 times root 5 would be 5. And then you've got to times it by the minus 2 as well. So 5 times minus 2 would be minus 10 there. Okay. And then I've got minus 2 root 5 times 1. So that'll just be minus 2 root 5. Okay. So that's my numerator. We won't simplify it just yet. Let's just write everything down. Let's do the denominator now. So root 5 times root 5. That'll just simply give us 5. Because that would be the same as root 25. And then simplify that, that'll give you 5. Root 5 times positive 1 will be root 5. And then minus 1 times root 5, they'll cancel. And then minus 1 times 1 will be minus 1. So now, we simplify. I've got 3 root 5 minus 2 root 5. So that's just going to be 1 root 5, or just root 5. Like so. I've got 3 minus 10. So that's going to be minus 7. And then I've got on the denominator 5 minus 1, giving me 4. Okay. So if we write just in this form here that they've got, p plus q root 5, well, that's just simply going to be, so my p will just be my minus 7 over 4, so minus 7 over 4, and then my q root 5 will just be my root 5 over 4. Okay, and then that here, so this expression here is the required form. Okay, so p and q are just rational numbers here. So yeah, happy days. So that's 4 marks for that in total. So the next question again, we're getting probably into one of the trickiest ones here now. 5 marks for this. We've got to show that 5 divided by root 75 minus root 50 can be written in the form root a plus root b. And we should expect to find a and b to just be integers. So, before I do anything here, what I'm going to look to do is I'm going to look to simplify my denominator. So, let's just do that first. So, root 75 minus root 50. So, just like we did with the second one, we need to simplify these square roots now. Now, they've not given us any numbers here, so we're kind of just going to have to figure it out ourselves. But because root 25 goes into both of them, so 75 is divisible by 25, 50 is divisible by 25, I'm just going to use that because that will be my biggest square number. So this will be root 25 times root 3, and then this will be minus root 25 root 2. Okay, simplify this now, so that'll be 5 root 3 minus 5 root 2. There. Okay, So that's my denominator. So let's just rewrite our expression that we're starting with. So what we had is 5 over root 75 minus root 50, but we know this is the same as this. So rewriting that. Oh, root 2. And then we can simplify one step further here. If you've got 5 divided by 5 root 3 minus 5 root 2, we can divide through by 5 here as well. So what this is actually going to give me is 1 over root 3 minus root 2. Okay? And this is just easier to work with at this point now. It's going to make life much easier. And in maths, that's always the key idea. We want to make life as simple as possible. Now at this point here, we've got square roots in the denominator. So we need to rationalise, okay? So whenever you see kind of surds in the denominator, always think about rationalising, or can we rationalise? So again, I'm going to times through by the conjugate here. So this will be 1 times root 3 plus root 2. So again, it's the conjugate, so it's the opposite sign, okay? Divided by root 3 minus root 2 times root 3 plus root 2. So my numerator, nice and easy, that's just going to be 1 times root 3, then 1 times root 2, so that's just going to give me root 3 plus root 2, nice and easy. The denominator, again, you've only got to square this term and this term together, and then my last two. So root 3 times root 3, that'll just be 3. And then minus root 2 times root 2, so be very careful here, this will be minus 2, so not plus 2, but minus 2, okay? I can't simplify my numerator, that's just root 3 plus root 2. My denominator, however, 3 minus 2 will just be 1. And then because this is a denominator form, we can just write this as the numerator, which is just simply root 3 plus root 2. And notice we've got it in the form that they wanted in the question here. So my A is 3 and my B is just simply 2. And they're both integers, so you know that's a good thing there. So 5 marks for that, and that's our question done there. So another question here, just testing again, just making sure you're confident expanding brackets involving surds. So root 11 minus 5 times 5 minus root 11 here. Okay. So I'm not sure which method obviously you all use, but I use FOIL. So I expand my first two terms, so that's 5 times root 11, so that'll be 5 root 11. And then do my outside, so root 11 times minus root 11. So again, be careful with your sign here, this will be minus 11. So minus 11. Minus 5 times 5, so that'll be minus 25. And then minus 5 times minus root 11, so again, just be very careful with signs, this will be plus 5 root 11. And at this point here now, all you've got to do is just simplify, okay? So 5 root 11 plus 5 root 11, that'll just simply give us 10 root 11. And then minus 11 minus 25 will just be minus 36 there, okay? And that's literally all it is, guys. So these can be quite quick sometimes. Once you've gotten used to the, expanding your brackets, and you've got used to the rules of surds, these questions are really nice and easy. So the next one, now this is on the GCSE Spec, and it causes quite a lot of issues. So basically what you have to do is write 27 to the power of 2x plus 1 in the form 3 to the power of y, okay? Now this is something that you've got to be confident with, and it's basically, it boils down to being confident with your rule of indices, okay? The first thing I'm going to look to do here is take this 27, and how would I write 27 in terms of base 3? So what I mean by that is if you take 3 to the 1, that would be 3. If you take 3 squared, that would be 9. So we're still not at 27 yet, so let's keep going. 3 cubed, 9 times 3, 27, perfect. So what we're going to look to do here now is rewrite my 27 as 3 cubed, and then the power's still the same because we've not done anything yet, so that's to the 2x plus 1. And this is equal to 3 to the y, okay? Now, use your rule of indices, so when you've got a power raised to another power, you multiply through. So what we've got here is 3 to the power of 3 lots of 2x plus 1, which is the same as 3 to the power of 6x plus 3. Now, if this is equal to 3 to the power of y, remember, because this is the same base now, and it shouldn't sound silly, but I think a lot of people take it for granted. This equal sign literally means that these are the same number, right? So this y has to be the same power. If it's the same base, that power has to be the same as well. So in that sense, what that just means is that if we equate the powers, y is equal to 6x plus 3. Okay, so 2 marks for that. It caused a lot of issues on the GCSE, but it's something for A-level that you need to be very confident with. Okay, so that's that question done. And then we're on to the final question here. So 243 times root 3 is equal to 3 to the power of a. And it's very similar kind of to the last question that we've just done, right? So we've got 243 times root 3 is equal to 3 to the power of a. Now, again, I'm going to look to see if I can reduce this 243 to a base of 3. We've got a root 3 here anyway, so let's just sort that bit out first. So root 3, well, if we write that as a base of 3, the square root, remember, that's the power of a half. So that's 3 to the power of a half. So we've got 243 times 3 to the power of a half, 3 to the power of a. Now once we write this down as base 3 to a power, we're timesing it, so all we've got to do is add the powers, and that will be a. So we've just got to reduce this 243 now. So you've just got to think about how you write your powers of 3. So for example, 3 to the 1, that'll be 3. 3 squared, that'd be 9. 3 cubed, that'd be 27. 3 to the 4, that'd be 81. And then your next one would be 3 to the 5, which would be 81 times 3, which will give you 243, right? So this 243, that's the same as 3 to the 5. Okay, we're timesing that by 3 to the half, and that's equal to 3 to the power of a. Now, if you times him, you add the powers. So if you've got 5 plus a half, that'd be the same as 10 over 2 plus 1 over 2. So this is 3 to the 11 over 2, which is equal to 3 to the a. And again, just like we were saying before, if the base is the same, the powers have to be equal. So a is just simply 11 over 2. Okay, so that value of a is just that power there, which is 11 over 2. Okay, so that's this video, guys. I know it's been quite a short one, and it's one of the easier topics of the A-level maths. But if you're new around here, be sure to subscribe. I'm going to be running through the whole A-level maths and further maths if you sit further maths. And we will also run through applied as well, so stats and mechanics. Okay, guys? So, yeah.